we're given a range from 1 to 2005. 1 to 2005. So if we want to form the smallest set of numbers that are relatively prime but does not include prime numbers, that means we'll be dealing with 2 squared, 3 squared, 4 squared, sorry, not 4 squared, just prime numbers. 2 squared, 3 squared, 5 squared, what else? 7 squared. Then we'll keep on going. I'm not going to write all the squared numbers, but we'll keep on going until we get to 43 squared. 43 squared. 43 squared, is it less than? I think it's 43 squared is less than 2005. Yeah. Let me check 47 squared. 47 squared is the next prime number. Okay. Okay. So 43 squared is 1,800 and something. 47 squared is 2,200 and something. And 2,200 and something is already greater than 2005. So these are the numbers that we are using. These are 14 numbers. There are 14 numbers from 14 prime numbers from 2 to 43. 14 prime numbers. Alright. If we include this is the smallest set that we can form that we don't have prime numbers. No, this is the largest set that we can form that we don't have prime numbers. If we want to make this relatively prime number set bigger, we need to include a prime number. So we can now include, like, let's say we have paired 2 squared with 3 squared, 5 squared with 7 squared. What's the next? 11 squared with 13 squared. If we want to like add an extra number, it's going to be 15. Let's say we add another prime number. Wait, let me even. These numbers are not much to write. So let me just write them. Let me scroll to the top. So let's just pair them. 2 squared with 3 squared. 5 squared with 7 squared. 11 squared with 13 squared. 17 squared with 19 squared. I hope I don't omit anything, and I hope I don't include any number that is composite. 23 squared with 23, 24, 25, 26, 27, 29 squared. Then is 1, 2, 3, 4, 5. 31 squared. I think 31 is a prime. It should be a prime. 31 squared, 34, 35, 37 squared. Then we have I believe it's 41 a prime. I think 41 is a prime. Yes. 41 squared with 43 squared. So that's 1, 2, 3, 4, 5, 6, 7. Then remember we can also like do, instead of writing 2 squared, 3 squared, we can write 3 squared, 2 squared. So if you count the amount of elements that will be in that set, there are 14 of them. So if we want to make sure there's at least one prime number, all right, let's say instead of writing at least one prime number, we can include maybe, what's the next? We can include maybe 15 and 47. These are co-prime. 47 is a prime number, 15 and 47. So the amount of the least positive end that we will have, that will make sure there is one prime number, at least one prime number, is going to be 15. So it's going to be the squares. Then we can do front and back, so we just multiply by 2. plus 1. Plus 1. That's going to be. So that's why for this one, our answer is going to be 15. So this one is more or less like brute force than um actual proof by contradiction. So that's just how we basically get our answer. Oh my god, this is